Okay, so I'll switch to English to start this session. We'll be having a quite welcome. So this is a special, very special session for us here at the Lisboa ZX Spectrum Museum in Lisbon Games Week, because we are having as a guest on our stand Jim Bagley, a legendary developer for the Spectrum community and Spectrum platform.
Thank you again.
Not at all, it's more than deserved. And we are pretty much geeking out to have you here on the stand.
Glad to be here.
So we invited Jim, and he gladly accepted to join us at the conference to talk a little bit about the machine that it's just behind us, which is called the ZX Spectrum Next, and basically the story behind his participation on the ZX Spectrum Next, and the idea, the major facts behind the platform. From that point onward, we will discuss and start a bit of a conversation, but the idea here is to introduce audiences to pretty much the challenges and the story behind this platform. And then from that point onwards, we will just jump onto a very lightweight, quick questions and answers. And if you guys want to barge in and join in, you're more than welcome to put up questions, okay? So, Jim, first of all, thank you so much for being here. We are pretty much geeking out, as I mentioned. This is a wonderful moment for the museum. And so, if you could kindly just give us an overview and a story behind, well, the Spectrum Next. We pretty much know what the Spectrum Next is,
yeah.
But what was the story behind this and the first Kickstarter and so on? Okay?
Yeah, okay. Basically, I think it was 2012, or it could have been 2014. Anyway, it was a long time ago now. And I was doing a talk at a retro event in the UK. In Blackpool called Play Expo, and a guy called Enrique was doing a talk, and he came over to me and said that he was doing a talk after me, so did I want to come and, well, I might be interested in what he had to talk about. So I said, okay, I'll stay in and listen. So I did my talk about all the games I've done, and then he came on and he announced the Spectrum Next, and he showed renders of the machine, of what the design was going to be like, and said it was a Spectrum with an SD card so you can load your games faster, and a Raspberry Pi for an accelerator to do whatever you want to do with it. And then he's going on about how it came about, and then at the end of his talk, he said, "Has anyone got any questions?" And I was like, "Yeah, I've got a question. Where do I get a dev kit? Because I would like to have a play with it." So he gave me a dev kit sort of there and then, and I found out later that he'd given a dev kit to about 20 guys in total. About 20, not guys, developers in total. And I didn't know at the time as well, but most of them were doing, if not all of the others, were doing games. But I decided to do something different, because a lot of the times when I've been doing shows and talks or in emails with people, they've said that they wrote games in BASIC back in the day, but they didn't know how to do machine code, and they'd love to do machine code, or to be able to get like a sprite moving around, something moving around the screen fast or smoothly in pixels, and how do you scroll the screen. And to be honest, if you know the way the Spectrum screen's laid out, with the breaks it into thirds, and then it goes back up, and then it does the middle bit, and then it does, and the way a loading screen loads is how it's stored sequentially in memory. So to address a pixel at any given point is a nightmare in machine code for beginners, because you have to rotate bits around. It's just not even worth thinking about. So I thought, because it's a Spectrum, it was called the Spectrum Next, I thought, well, should it be the next Spectrum that could have come out back in the day? So I thought, what I will do is I will make it easy for the next generation to pick it up and get something moving on the screen. Because for me, when I had just any computer that I've programmed on, the first thing I do is get something moving around on the screen, and once you've got something moving around on the screen and you're using the keyboard or controller or whatever for input, and you've sort of got everything you need to make a game. And it's also like back in the day when we first got these machines, it's like, oh my god, I did that. I controlled something moving on the telly, because you could never control the telly other than the remote to change the channel. And so to have this computer that you could then control things on the screen, but not only that, but to be able to make a game is an incredible feeling, and it's a huge buzz. It's why I make games still, even like today, 38 years later. So anyway, what I decided to do was to make it easier for the people who wrote games in BASIC. I thought if I give them a feature with using the Raspberry Pi to add hardware sprites so that they can move a sprite across the screen without having to do any like calculating the screen address, rotating the bits, the image, so you can get it to scroll
have the machine
smoothly.
just do it for them, right?
Just have the machine do it for them with one simple poke. At the time, I was using pokes, but I'll go into that a bit later. So I was using pokes to set the coordinates for the sprites and everything, and then I thought if I add extra colors, like an extra mode in the background, so that you could add more colors, so like you get rid of the attribute clash, because although it was a nice feature of the Spectrum, I was focusing on a next version which would probably have sprites and more colors. So hence I did the extra colors in the background. To go back to the bit I was talking.
You were basically stating that you started putting up the bit blitzing stuff, and from that point onwards, it was growing up onto the Raspberry Pi. And eventually, it got integrated into the thing, right? Because the Kickstarter started happening.
In I think it was 2016 was the first Kickstarter. We started with a goal, and then it beat the Kickstarter beat the goal.
Because the original machine was very basic, right?
Yeah, the original machine was very basic. It was just the SD card and the Raspberry Pi for the accelerator. But because we got the stretch goals and we were adding extra, we were thinking up the stretch goals as they kept getting beaten.
Yeah.
And then one of the stretch goals was a larger FPGA, which meant that we could put the...
So it would be a larger chip that would have more logic ports there, right?
Yeah, so we could put all of the features that I did with the Raspberry Pi onto the FPGA, which would then also free up the Raspberry Pi for other things. Plus it also meant that anybody who had the base machine, which didn't have a Raspberry Pi in, could have all the extra nice features.
So you could have all of that stuff that you had been working on the Pi.
Yeah, and so, I was talking about the basic. I was using the pokes for the sprites. So when we were continuing to develop it, a guy called Gary Lancaster was doing the next basic. Yeah. And I was badgering him like mad. I said, please, Gary, do me a favor. Can you add it's like the biggest favor I'm going to ask you. It's like, can you add the extra features of the next, like hardware sprites? Can you add that to basic? And at first he was like, I haven't really got the room. But he went away and he came back and said, well, I've added one of the extra ROM banks, and so we can use that and add more features. And so that he added the...
So you finally had in BASIC the same access to the same features to putting sprites back and forth.
So instead of using pokes, we went to having a line like sprite, and then you give it an image number and coordinates, and then and like some attributes to say whether it was flipped in the horizontal or vertical or rotated 90 degrees. And then it just meant that people who wrote games in BASIC could then have a sprite move across the screen very smoothly and at full 60 frames or 50 frames a second or 60 frames depending on which country you're in. And so it was, we thought it was great, and everyone who saw it thought it was great. But what amazed us was when it went out to the backers,
Developers.
and they started getting to grips with it and learning what they could do with the BASIC and with the sprites. They started showing demos of the games that they'd done, written in BASIC, and this blew my mind and everyone else's mind, because the games that they were doing looked and felt better than a lot of the games that were written back in the day in machine code. And you're thinking, this is BASIC? How is it like? And what is even more amazing is now that it's been out for a while, it's just getting better and better because they're exploiting it and finding better ways of doing things. And it's been like a real eye-opener, and it's just been brilliant. Not just for me or the thingy, but for the whole community, because it allows other people who wouldn't have originally been able to make a game that was so smooth and running and have an animation and stuff. And they can even get to a point where they can sell them, and which would mean, even if they don't sell them, if they just give it away, it would mean that there's more games on the machine, which would bring more people to want the machine, and more people wanting to make games. And it
gets into a positive feedback loop, right?
And just it just ends up being great for the community.
Really cool. So that's a great intro for the stuff. I would have a couple questions, but I would first know if anyone has some questions for Jim to start. Otherwise, I'll ask one myself. So we have one person on the audience. So Rui, I'll go for you.
So I'll try two questions. One, what is the best feature you got on the Next? And what's the best feature that you missed that couldn't get into the Next?
Oh, good questions. The best feature, obviously, is the hardware sprites, because that has enhanced BASIC to the point where they can make games like in BASIC, and not just make games, but make great games in BASIC that are really playable and everything. So, because back in the day, when I was making games in BASIC, because it uses floating points in BASIC, it's just way too slow and it struggles. So, if we'd have had that back in the day, it'd have been amazing. So yeah, that's I think is the best feature. And the thing not having, I would like a multiply, a 16-bit multiply with a 32-bit answer. I think that would be great.
It really goes to show, I guess, that how important what the platform provides you is for leveraging the quality of the products.
Yeah.
Because you could do some of this stuff back in the day, right?
Yeah.
But it would take so much more skill and time and
so many more instructions.
Absolutely. And sometimes you'd race to actually get the timings right, because you just wouldn't have enough time for the refresh to put all of those instructions. And this is the main bottleneck, right?
Yeah. Like if you Cabal, which was on before. Right, I don't know if you noticed, but it draws the game, and then it chases the raster, drawing the bullets.
Yeah.
Because you'll see flicker now and again.
I promise you guys that we'll be doing a very techy session one day that will showcase all of these nice game development tricks, like this magic race the raster, which is one of the most important tricks of the trade to actually get smooth frame rate.
Yeah.
So that's two questions done. More questions, because I have a few. I'll start with one of mine, okay? Mine's a bit more of a philosophical one, okay? So I'm looking at Beggars in Space, which is a recent game you did. It shows by the main character.
It's a game about me, but I didn't do all of it because it was. Do you want me to go into it? Or
No, you will go into. Let me save that for next question because my main focus is not in beggars.
Yep.
My main focus is looking at the screen.
Yep.
Crap, that kind of looks like a Commodore Amiga. That doesn't. That doesn't look too much like a Spectrum these days.
Yeah.
So how do you harmonize this? Because the experience was enlarged, right? The experience was made better. But is it still Spectrum? How is the reaction of the community in this?
There was a lot of it's not a Spectrum.
I don't know where they got that one.
I don't know where they got that one. But we kept the aspect ratio, we kept the colours low. We could have gone to 24-bit because we were using HDMI, but we didn't. We kept it 3 bits for red, 3 bits for green, 3 bits for blue. So yeah, it's kind of it's not as good as the Amiga because the Amiga had 4096. We've only got 512. So
it's a better Spectrum.
It's a better Spectrum. Yeah.
Okay, I'll go with that.
Yeah.
But you still pretty much program it the same way. So
it's still
the same memory
Z80,
map.
but we've got a few extra
Sure.
instructions that help.
You have banking and you
we
have all
banking
of this stuff that you would
got
get, for example,
a lot more memory.
Yeah, in the 120K you'd get something like that. So it's an evolution.
Yeah.
All right, so that's one. Another stuff which I would love to get into is regarding the way in which you implemented, as Jim was explaining, most of this implementation was in getting graphics to work better, basically, in guaranteeing that you have primitives that actually move bits around back and forth. This is usually called bit blitzing, right?
Yeah.
And so, if you look at this stuff and the stuff that people are doing, it's a bit more complex, and you actually did something which I loved. You started a YouTube series, which was basically coding was it a Sunday or a Saturday?
Yeah, it's every other Sunday.
Okay, every Sunday, right?
No, every other Sunday.
Every other one, okay. Which was basically a series of tutorials being done live, in which you'd go through the basics of each series of topics on the Spectrum Next development.
Yeah.
This got quite a bit of traction, didn't it?
Yeah.
So what were your experiences in this? What were people expecting? What were you expecting from this, and what did you get in the end?
I don't know what I was expecting. I was just doing some tutorials to help people to program, to get to know the new features, like using the sprites, using the layer 2 in both basic and in machine code. And also the guide was to sort of do the basic and then try and go
optimize
through not optimize. Go through the basic and say how you would sort of convert that into machine code.
Cool.
And then do the machine code alongside saying what the basic equivalent of the machine code instruction was, and then it might help people learn what each of the instructions are in machine code and help give them a basic understanding so that they could then put their own bits of routines together to do games and take it further.
And did they do that? Did they divert onto the exercises every week?
Yeah. People have they were following along, and some people were following along but going on their own path, because I was telling them that I want them to do their own. No, you can copy by all means, but I would like it if you be creative and change the graphics, and if you feel confident enough with the code, change the code. And people were, so it was great.
One good idea would be to actually get all of that stuff together and make a Coding with Beggars evolved, in which everybody would showcase the stuff they made and how it would differ, right?
Yeah, it would be. Maybe one day, because I intend to go. I took a break because I had COVID and stuff like that, and other things happened. So I had a little break from doing the tutorials, and then I was going to get back into doing them recently, but it's been show after show after show. So I've done a lot of traveling and stuff, and so I think I've got one more show on the 2nd of December, and then it's Christmas.
And then it's Christmas.
Yeah, and then hopefully I'll start again with the thingy in the new year with the tutorials.
So eventually you'll resume.
Yeah.
Nice. Looking at the machine and looking at the way in which the machine is set up to be very, very, very similar to the original. It's heavily inspired in the original Spectrum, right?
Yeah, it was designed by Rick Dickinson and Phil Candy, who is his business partner. Unfortunately, Rick Dickinson died just before the first one shipped, so he never actually
got to see the finished machine, which is a pity, right?
Yeah, a really big pity. But Phil Candy has done a terrific job because he did a lot of the design for the original, for this version, and so yeah. And
absolutely. This was done on a very tricky moment, right? Because Kickstarters and Kickstarters are always prone to not going to the full extent, right?
Yeah.
But there was a very dramatic case, which was the Vega, the initiative, which was a kind of a portable Spectrum thingy, which was promised on very, very high expectations.
It didn't go too well.
Didn't go too well.
And the problem is, we kind of got a lot of backlash for that, and we were like, why are we getting backlash? It wasn't.
Maybe not now, I mean, guys,
Yeah. It's a different company, different people. We want to bring out the next. So, I mean, admittedly, this was the main reason that when we did the Kickstarter, we thought it wasn't going to make the goal.
But in the end, it turned out okay, right?
Oh yeah, it reached the goal relatively quickly. And then it continued, and instead the goal was 250,000, and by the end of the Kickstarter it got up to 723, if I remember correctly.
Wow, that's quite a lot.
Yeah. And then, do you want to go into the second one now, or do you want to save that for another question?
No, please do, because this was not the so they had two moments, right? They had Kickstarter 1, which was this production run that we have here, and now on the boats at this moment, as we tape this,
going up the coast.
So on the boats, there's plenty more ZX Spectrums on a second Kickstarter initiative, and you guys also ran that to huge success, right?
Yeah. Although, go back to the first one again. We had, well, not only did we have the issue with the Vega, we also had issues with some
of the pieces, the keyboard,
companies,
right?
The plastics company that we did, we originally had booked in to do the case. When we said, right, let's go, they were like, you know what? We don't want to do it now. It's like, what do we do now?
Because everybody was doing this from scratch, right? So everybody was learning the manufacturing process.
Yeah, we didn't know anything about manufacturing or getting anything done.
So everything that could go wrong could potentially go wrong, and sometimes did.
Wrong. Yeah, everything went wrong, and even something that we wouldn't even think would go wrong went wrong. So yeah, and then the keyboard was very heavy to type on because we had to use 3 layers on the membrane because we wanted to keep it so the board could fit inside an original Spectrum rubber keyboard. So, but we wanted to have the extra keys, so it would be like the 3 layers, like the plus 2 or the plus 3?
Plus,
or was it
2, I guess.
Plus 2 had it as well. So, anyway, so we had 3 layers.
Yeah.
But we had issues with the connections, so you had to like really press the keys heavily for like the three layers to connect.
Yeah.
Because like sometimes only one layer, two layers would connect.
The analog world always sucks compared to the digital
2
one.
layers would connect, so it would just be like you press the cursor key and you get 8888, and then you'd have to delete them and you put 000 because you're pressing the delete key and not, which is shift and 0. So it was like,
probably a micron thing, right?
And we were like, this is a thing, a project of the love for the Spectrum, and we wouldn't want that for ourselves, let alone to sell it to people. So we thought we're not settling for a shit keyboard. We're gonna make it a good one. So we were trying all sorts of things. We changed the pads that had to connect when the keys were pressed, and we tried like offsetting them so they were, and to get it thinner so that it'd go closer.
Just a tiny bit.
Just like micrometers or whatever. And yeah, everything we tried didn't work. And in the end, I can't remember who it was that came up with the idea, but we decided to put it on the FPGA.
Yeah.
And have all 16 extra extended keys be a single key. So we went back to two layers.
Sure.
And then it would go to the FPGA, and the FPGA would then put it into the key matrix.
Yeah, and then decode it.
And so that saved it, and then it made the key presses really light, and it makes it like as good as a decent new laptop keyboard.
But I believe that's one of the keys of the success, that eventually you got through all of these dramas, but you always ended up pulling through, and the amount of love you had for the final product and the stuff that you were trying to achieve was really showing to everyone. So I believe when you did the second Kickstarter, this was more than clear that these guys were more than willing to put their hearts into solving problems, to making this happen. So that was clear for everyone, I guess.
And another thing as well was the case.
Yeah.
Because the plastics company that we used, the second plastics company that we used, the case would, when they took it out of the mold, it would warp. So like we had to put extra scaffolding on the case to make it more rigid, and then screw it in place, and it was a nightmare. But yeah,
so scaffolding is basically all of those ridges, those plastic ridges that go inside, just to keep shape.
Yeah, just to stop the warp, to make it like flat.
Amazing.
And
then you got to the second Kickstarter,
and
right?
then we went for the second Kickstarter, and that was amazing. Like with the first Kickstarter, my phone was vibrating every
and new purchase, new backer, new backer, new backer.
It would vibrate off the table.
Oh wow!
Like the vibrations were getting interrupted with more vibrations, and it was hilarious. But it went on, and
it reached the backing goal rather soon, right?
Yeah, but the second one was even worse, because within 54 minutes, we reached the goal of 250k, and then it didn't stop. It just skyrocketed. It just kept going and going and going, and past 1 million. And like,
that's crazy.
How is it? We ended up with 1.8 million.
Amazing. That's crazy.
Backers.
And then COVID hit, and then and then the component shortage hit.
Yeah, we thought it was going to be easy. Like we've got the production set up and everything, and it should just be another run. And then COVID hit, and then the global chip shortage, and then to make it worse, like not only was it was going to be like 66 weeks for delivery of the chips.
Yeah.
But then they decided, you know what? That FPGA that you were using, we've scrapped it. Didn't even tell us. There was no announcements. Normally, the companies would say, right, this chip, it's end of life. We're not going to be producing it anymore. And you've got 2 years to buy as many as you need, but you're going to have to...
or bye-bye.
Yeah. But that 2 years would have been great if they'd let us.
But the chips would be there, right?
But because they wasn't, it was just dropped like that.
For you guys to understand, this basically means that the heart of the computer, the FPGA, that chip which is programmable to whatever we want, well, it was not available anymore. And these guys had to do an amazing thing, an amazing feat, which is to start the travel and to start the flight with one engine on the plane, and then mid-flight
we started with no engines on the
plane.
With
no engine on the plane.
Just pushing it along the runway.
And then mid-flight, rebuilding the plane around the engine, and then changing the engine, and then building the plane mid-air, and then hoping to land.
Yeah. It was It was crazy.
So it really was.
Yeah.
It really was amazing. And right now, the KS2, the Kickstarter 2 ZX Spectrum Next,
Yeah.
they do come with a new FPGA.
Yeah.
And, well, it's more powerful than the original one. So
Yes.
this brings you, I believe, a bit of a conundrum, right?
Yeah, this was always going to be a conundrum. We've got a bigger FPGA, it's more powerful, and it's got a little bit more on-chip memory. And it's like, do we use it or don't we? And
Absolutely.
we thought it's best not to, because we wanted to keep the backwards
platform clean,
compatible.
yeah.
So that every Next would be like equal.
The Next.
Yeah.
One Next.
One Next to rule them all.
Yes, that's it. All right, so this eventually ended up, as we mentioned, Kickstarter 2 ended up being quite a huge success.
Yes.
There's this other platform which is 100% compatible with the Next, which is the Engo.
The Engo, that's a great machine.
Which is an amazing platform.
Yeah.
It was my quick fix because I didn't make for Kickstarter 1.
It was a lot of quick fixes for people.
So I got my next quick fix by buying an Engo. I actually bought two.
Yeah.
So there are plenty of devices right now in the wild, right?
Yeah.
And if you take into account that you're about to put a few more on the market, how many devices overall?
Right. With the Kickstarter one, there was 3,000 boxed units and about 400 board only.
Yeah.
And then there was a few years ago, we knew that there was definitely over 1,000 Engos. And that was
there's certainly
quite a few
plenty
years
more.
ago. There's plenty more. I don't know how many more. We've got no idea, but
certainly a
there's
few
lot
thousand.
more. Yeah, I reckon there would be as well. And then the second Kickstarter, there's I'd normally say 6,000, but to be precise, it's 5,830, if I'm correct. I think that was the number. And we've also got Enrique's also got 10,000 email addresses of people wanting
On the waiting list.
on the waiting list.
Wow.
For wanting one.
So that basically means that on top of these about 12,000 something overall, you still get probably 10 more to deliver if you do another Kickstarter.
Yeah.
Which you probably will, won't you, Jim?
Very, very likely. Yeah. Well,
that's good news, guys.
The thing is, the more units that are out there, the more people that can have them, and the more people that will hopefully make more games, which will be better for the community altogether.
So this basically means that you'd get at least 20,000 devices in the wild or something along these lines, probably a bit more.
It also means that it might incentivize more.
Of course, because this creates this feedback, right?
Yeah, the original developers.
So more
or even
developers,
developers,
more demand for the devices.
even new developers.
Absolutely.
Yeah. So it's.
So you're building a new platform. This ZX Spectrum
Watch out,
Next.
Nintendo.
Absolutely. Right, absolutely. And hardcore guys at that, because all of the community is very, very active, right?
Yeah.
And people which some of these are people that are from the old days, right? So they were jumping from the original Spectrum platforms.
Yep.
But you still get people that are now jumping aboard to the platform, correct?
Yes.
How is? Do they share their experiences? What are they looking for?
I don't know. I think it's just a really nice platform, and people like what they see. They like programming on it. Everyone who's used the basic say it's really powerful. You know, they got the fact that you can use functions now as well, and the fact you've got the extra hardware and you can run it like up to 28 megahertz, and it just makes it so much easier for newcomers to pick it up and play really well.
I believe one of the things that makes it really appealing is that this is a comeback to a moment in time in which you'd be able to understand the whole platform. So you're able to understand the machine back to back. What's happening memory-wise on the CPU, on the display processor. And in this case, you do have a display processor. So in this case, it is correct. But you still get a full grasp of the thing. So it makes it such a nice, wonderful experience to be able to own that experience. To be able to look, I did that.
Exactly, and that's what, well, for a lot of programmers that I know, it's that I got something moving on the screen. That's what fires the desire to continue and make it into a game and just experiment with it. And if we can get that into the next generation of kids, that'd be brilliant.
You know, at the museum, we do have this very clean goal of making this also a learning platform. So having all of these devices and all of these experiences that we have around us being something that people can build upon and create knowledge for new kids and newcomers that come onto the programming stage or the electronic stage to understand the basics and build from that, right? So that's clearly one of those. But there's also another component to this, which was the fact that the original Spectrum, it came with not only the tiny slivery manual for connect here, connect there, but also with a very hefty one, which was written by Steve Vickers, which was basically allow me to be redundant, a learning program for learning how to program a computer. A learning program to learning to program, right? And it really got many people started into the basic language and got started into this concept of exploring and thinking with it. And one of the things I loved in the original Kickstarter, and which you replicated so well, was that when you did the manual for the Spectrum Next, you pretty much emulated the same idea and the same concepts from the original ZX Spectrum manual, right?
We wanted to give the same feel of the original Spectrum, so
So this concept that you would open up the box for Christmas and you plug the computer onto TV and open up a manual and doing
stuff and exploring and building teaching yourself how to program.
And many people love that manual, but I heard that the manual for Kickstarter 2 is so much better. Is it, Jim?
Yep.
That's a high bar to go over,
I know. It is. The Phoebus Docus, I hope I pronounced his name right, and a lot of the people in the community helped make the first one, and he did an amazing job at that. But with the second one, they've added a lot of the new features, and so not only have they added the new features that have been developed since the first one was published, because the Next Basic and everything has changed a bit since
so they
then.
Updated it?
It's just updated, so it's now printed in colour as well.
Woohoo!
So we have some colour in there instead of black and white pictures. So
amazing. So Jim, to close up, what's next for the Spectrum Next? And I've been first of all, what's next for you personally in the Spectrum Next community? Do you have any major plans of building stuff? And what's next for Spectrum Next regarding, probably new Kickstarter, but also, would you consider new form factors and stuff like that?
It would be nice to. So I will leave it there.
New form factors, such as a portable, lovely device, for example?
That would be lovely, but we'll leave it there. And I have the games that I've been doing, the network games, and also I will be back on the tutorials early next year.
Really cool. So really keen and hoping for that, huh?
Yeah.
So once again, if nobody has more questions, I really need to thank you for your time. You were amazing here in Portugal, both here on the booth, with the indie developers.
Yeah.
We'll be doing tonight. We'll be doing another session in the main stage where you'll be talking probably a bit more in depth about your career and yourself and so on.
Okay.
Would be hearing that with a tiny, a Christmassy eye, and the fact that this is something that we all share. This concept of how the bedroom coders evolved into really seasoned professionals that spawn a broad range of platforms and a broad range of knowledge. So really keen to hear that. Thank you so much for being with us, both in the conference and overall. Your presence is amazing. And as I mentioned, I'll close as I started. This is a geeking out experience. So thank you so much for being with us, Jim.
It's an honor. Thank you.